What I want to do with this brief commentary is just to explain the structure of the tables. Now, these tables you'll find in the booklet that I told you to purchase. That is the Thermodynamic and Transport Properties of Fluids by Rogers and Mayhew. And basically, this booklet is listing experimental data for, in this case, H2O, where it's been increased in pressure and temperature and changed phase from its liquid phase through to dry vapor, and there's also a section on superheated vapor. So these tables are just simply used if we know, for example, the temperature and pressure of our H2O, then we can just go to these tables and we can extract enthalpy or, if need be, entropy values. So the first page there, you'll see that the reference column is temperature. The next one we have saturation pressure. This one here is specific volume. In the center of this page here, we have our enthalpy values. We have HF, which is our enthalpy of saturated liquid, HFG, which is our enthalpy of evaporation or vaporization, and we have HG, which is the enthalpy of dry saturated vapor. Out on the right hand side, we have our values for entropy, and again SF, SFG, SG. SF is the entropy of saturated liquid, SFG is the entropy of vaporization, and SG is the entropy of dry saturated vapor. So if we know that our temperature, then we can go to this page and read off our enthalpy and entropy values as required. When we go on to the next page, you'll see that the reference column now changes from temperature to pressure. So we now have pressure, and that theme will continue for the next few pages. We have pressure, saturation temperature now, and then specific volume. It's also added in a column for internal energy. But here again are our two columns for enthalpy and entropy. And you'll notice that they are per kilogram, meaning specific. All of the quantities are per kilogram. So on this page, it ranges, the pressure ranges from 0.006 through to 1 bar. And on the next page, it picks up that pressure at 1 bar and continues over the next few pages until we reach our critical point. So for example, at 1 bar, H2O will saturate, i.e. it'll begin to boil at 99.6 degrees Celsius. And there are our values for enthalpy and entropy. So it's a case of just looking at our pressure and temperature, coming to the tables and reading off our enthalpy values. Now, if the steam is in its superheat condition, then we go to the section in the booklet that is for superheated vapor. And the way to know if a particular sample is in its superheat phase as opposed to its saturated phase is to look at the pressure and temperature. For example, if we look at 1 bar, if I was to say that the steam is at 1 bar and it's at a temperature of 150 degrees Celsius. Now you'll see from this entry here, the saturation temperature at 1 bar is 99.6. So if the temperature has been raised at 1 bar to 150 degrees Celsius, then the steam is superheated. In other words, it's gone above its saturation temperature at its particular pressure. And the degree of superheat is the difference between our 150 and our 99.6. So whenever we're given a pressure and temperature, and the temperature for that pressure is above the value listed in the tables, then we have to go to their superheat steam table section. So further on in the booklet, you'll come across the tables for superheated steam. Down the left-hand side, we have a pressure, and in brackets underneath, we have the saturation temperature. That is our boiling point temperature. The first column to the right of that lists the properties at saturation for volume, internal energy, enthalpy, and entropy. These are values of dry vapor as they would be listed earlier in the booklet. And the main pane on the right hand side is giving us our values when the vapor has been taken above its saturation temperature. So again, for example, if we look at 1 bar, like we did just a little while ago, then if you recall, the saturation temperature at 1 bar was 99.6. Now, if the temperature has been raised to, for example, let's say 150 degrees Celsius, then what we have to do is take our 1 bar, and let's say we want to find enthalpy. We look at our 1 bar row and look at our enthalpy and keep coming across until we hit the column for 150 degrees Celsius, in which case the enthalpy at that point is going to be 2777. That is 1 bar 1 bar 150 degrees Celsius. And that's the theme that you need to follow. Whenever you're extracting enthalpy values or entropy values from the tables, then look at the pressure and temperature. If it's at saturation, then we take it from the earlier pages in the booklet. If the temperature has gone above saturation, then we need to come to our superheat steam tables until find our pressure and come across until we hit the column for the temperature, and then read off the enthalpy values. So, as I said, hopefully you've bought this booklet by now. You will need it. We will be using the chart later on, which makes life easier, but the booklet is still something you need. And have a look through it and try and get familiar with the layout of the tables. And as always, if you have any questions or queries about it, then simply get in touch.